Hello, everyone. This is a group project video report for the course 11611 Natural Language Processing. Our group name is Never Lose Passion, and our team includes Sarah D, YeRin Han, and Qiaochu Wang. The goal of this project is to create an automated question generating and answering system. I will first talk about the first part of the project, the question generating system. Then Sarah will talk about the second part, the question answering system. And last, YeRin will talk about the motivation for some major design choices. So for the question generating part, we use spaCy dependency parser to get the dependency parse tree structure of a given sentence. And based on the return information, our system can determine what kind of questions can be generated and how to generate these questions. For example, for the sentence, Harry Potter bought a wine in London at 9 a.m., we get a parse tree structure like this. So the first kind of question we can generate is a yes/no question. It is pretty straightforward. The first step is to analyze the root verb. Our system can recognize whether this root verb is in its past tense or not by checking the tag, whether the tag is VBD, VBZ, or VB. And our system can also check if the verb is a be verb or not. The second step is to add question word do, does, did, is, was, are, etc. based on the information we get from the first step. And the last step is processing. For example, change tense of the root verb to its lemmatized version and add question mark, etc. The second kind of question we can generate is when-where question. For this kind of question, the first step is to check whether the when-where questions could be generated from this specific sentence. So basically, we check whether there's a prepositional term in the sentence. And if there is a prepositional term in the sentence, we check the named entity recognition if it contains the GPE, LOC, or the time date. The second step and the third step are similar as before. And for the last step, we have to remove the prepositional term, which is asked for. And here is a very simple demo. For the sentence, Harry Potter bought a wine in London at 9 a.m., our system can generate several questions based on this given sentence.
For the question answering portion of the project, there are multiple steps. We first pre-process the article. We save time by doing this by only having to annotate the article once and then using spaCy's annotations multiple times for multiple questions. Additionally, we have to get rid of the non-sentence-like artifacts such as new lines or brackets or parentheses that don't add much to the sentence content. Additionally, we also make sure that all sentences end with a period to eliminate combined sentences, which mess with trying to determine the similarity of sentences of different lengths. We then extract all named entity recognition words, non-stop nouns, the root verb, and the question type from the question using spaCy's transformer model, which gave the most accurate root verb out of the models we tested. Next slide. We then filter the article sentences, removing sentences that don't have all the named entity recognition words or the non-stop nouns that the question has. Then, depending on the question type, we also check if the sentence can provide an answer. For questions that ask how long, we'd expect the candidate sentence to have a date word we can return. After we've reduced the number of possible sentences, we find the sentence with the highest non-stop word similarity to the question. The sentence with the highest similarity becomes our answer. Next slide. Usually humans don't respond to a question with the whole sentence, so we only return the words that are relevant to the question. We do so by question type. For example, if the question asks a yes or no question, we can compare the root verbs of our selected sentence with the question and return a yes or no answer based on that. Note that we by default answer no, since if we can't find something similar to the question in the article text, we assume the answer isn't there. Additionally, we can ask a who question. We expect a person or an object so we can extract and return that from the sentence. We can achieve similar results with questions like where, when, and how many. Next slide. So here is a simple answer generating demo where we take this article text and the questions, how old is Harry Potter? Does Harry Potter flee with his luggage? And who delivers Harry to the leaky cauldron? And as you can see, our answer generating function correctly generates 13 yes and the night bus.
From now on, I'll briefly describe the major design choices that we made for our question generating and answering system. Our model used two pre-trained models from spaCy to create a dependency parse tree that describes syntactic structure for each input sentence. By creating it, we checked a part of speech for each sentence, found a root verb, recognized name entity, and checked the tense of the root verb.